Hello everyone, welcome to my YouTube channel. Today we are discussing about very important topic which is around flood hydrograph. Actually all of people who is working in the industry which is related to the water, so they knows about the importance of flood hydrograph. So for specifically for Indian condition, how we are deriving a flood hydrograph. So there are series of report which was prepared in late 90 by Central Water Commission. So they have prepared multiple reports for a different basis. Before that, there was a committee which was led by Dr. A.N. Khosla. So they have decided that earlier for a hydrological purpose, they are utilizing some empirical relationship only to derive the hydrology. So then that task is assigned to the Central Water Commission, and they have created lots of flood estimation report for the different zones. So in the this part you can also look into that what are the zones which was already prepared. This report is already in public domain, so anyone can see these reports, and there are different formulation for the different uh, different zones you can say. So what we tried actually, because these reports are available, people are also taking it as a standard. So we also tried this only to convert these reports formulation using IoT, because now it's a time of AI and programming and all those things. So people are also doing, but as a company, PNDT Soft Solution and the team of PNDT, they think that because we are doing this exercise for our consulting works, research projects also, so why not to that means digitize those things like item and all those things for every zone and try to create a IoT version of this flood estimation report. So finally, just before Diwali, we succeeded, and we got some of the good results, and we are trying to present here that how it is working. Although this particular programming and all those things on a local host we have not launched yet, but we are trying to do with the support of investors and all those things. So what we are trying to present that it will save your time, and if once it's a tested proof check-in, then it will be used for industry. Either it is a large industry, small industry, bridge, culverts, drainage, everything it can be used. So that the purpose of our team is only to make it easier for the people who want to save their time and also want good results and good reports, or you can say fairly precise reports according to that, because creating a flood hydrograph also required lots of technical inputs, like how you are making S curves, what the unit hydrographs, so how to present those laggings, everything. So if suppose you are technically somehow you are not capable to do that, so what we can do that we can utilize those tools to get the flood hydrograph for your design purpose, so that you are getting a reliable value for a flood peak. So in that during that preparation I will show the version also, that means how it is creating those things or flood hydrograph over the command prompt. So lots of tools have been used, like you can see on the screen. There are like Excel, Python, Streamlight, Pandas, Plotly, OpenPy, Excel, NumPy, Excel Wing. So multiple things are involved in that to prepare all those things, like something data preparation, data digitization, everything has been done, and it's a fairly working, because we have also tested for the some of the reports. I will show some of the results how it is getting generated if you are having some GIS based information, because that is required for a flood hydrograph preparation, and some hydrometeorological data like rainfall, design rainfall. So going to that, I am just trying to share my screen. So first thing what we are trying, we have prepared all those things. So first we have to start the command prompt, because that is our working. When we will host that, that means it may come in the format of, you can say, application or something like that. So that's what we are trying to do. So in that you have to give some of the instruction to that command prompt. So actually first we are trying to, that means where our this particular folder is located, because first we have to locate the folder and then In that folder there are programs, like programs has been done already. So we are trying to just create those programs before you. So just go to this and run this program on a command prompt. Okay, so when you run this program, so that means after maybe some time, there is a local host. I already said that it is not directly like launched on a websites and all those things, that we are trying to connect over there. So something is running, because after that you will get kind of a portal that means what the data is required. So this is the total deployment of all those things. Suppose we are having a different zone, as I have shown already that you are having a different zone like North Brahmaputra, South Brahmaputra, Ganga, Betwa. So like people who are aware about that hydrology, or these are the zones. So you can choose your zone. Suppose you are in a zone 1, zone 2, zone 28, 2B, 1B, 7, 6, whatever be the zones. So you can select your zone. Here I am running for the zone 1C, because one interesting factor is there. So I will just mention in this during this running also. So I am running 1C, which is a Betwa subzones. Okay. So I am taking just a value of area is around 154, and length is around, it's some hypothetical value at some location, and slope I am taking like 2.6, and rainfall as it is. LC I have taken a 7.5 kilometer. Now I am just submitting this value, and it will running the model, whatever the prepared model over there. And it will take some time, but maybe less than a minute you are getting a hydrograph. So now the peak discharge value is like 446.34 meter cube per second for that particular GIS characteristic, like geographical characteristics over there. So that is fairly easy to use. You have chosen the zone. In that Betwa zone, why I'm just representing this one, that means this model is sensitive or not. I would like to just present that model is sensitive or not. So in that zone, actually the value of LC, like LC is the length from the centroid of the watershed. So it is not effective. Like whatever be the value you are changing, it is not effective, because for a unit hydrograph creation, if you just look into the CWC flood estimation report, so it is not there. So just I am changing that, that means this program is sensitive or not. So I have changed this like 7.5 to 5. So if this particular items is attached with that, so our value will change, and I will try with the some other parameter change also. So I'm just submitting and running the model. So now you just see that the value of flood peak is same, because LC is not effective in that zone, and it's if you just go to the unit hydrograph formulation, so it's not effective. So like our formulation is good, and we can also test for some of the like latest studies which has been done by any agencies, so that we can check. And some other things sensitive, like if suppose I am changing the area. So I am changing the area from 154 to 250, and then I am just submitting that, because area somehow its flood peak is dependent on the area also, because the catchment area is more, so more rainfall is coming to the particular outlet. So the model is running, and after that if you just look that value has changed, like it's increased. So it's a but obvious that when you are increasing your catchment area, so it is increasing. So up to this point, I would like to say that, and I would like to congratulate my all team who has worked very hard on that, and we are trying to do that to facilitate the industry as well as the agency who is working over there, to like it's a kind of you can say computerization or digitization of all the data in the format of all the formulations, so that it will become a user friendly and the people will use for the purpose. So thank you very much.